So hi engineering janta, am I audible and visible to you people? Just tell me once if I am audible and visible to you guys. If I am visible and if I am audible, go ahead, tell me in the chat section. You can simply type out a yes. Great, 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 great. So I am audible and visible. Great. Let's proceed with today's lecture. And I would start off from where I left. First of all, to all my dear students, my sincere apologies, but I was not well. Henceforth, the session that was being scheduled that day on Friday was postponed because I was severely ill, and now I'm back. So I'll explain you today from covariance again, because one homework I gave to you, and I deliberately gave to you that homework, that I had given you a data set. I had asked you that you tell me whether it is a coincidence and whether it is a random thing that's happening, or is it something that I'm wrong for, I'm wrongly doing, am I at a wrong footing, or I'm picking up wrong data sets. Fine. So I'll make sure that you are in tune with that and you are revised with that. Thank you so much for all the compliments, but focus here on studying. Fine. Now, coming to the covariance portion, if you correctly remember, I had given you that covariance of x with respect to y, or with for two variables, looks something like this. Right? That was the formula that I gave you. Interestingly, that day nobody pointed out, and that's why, that was the reason that I left the lecture on that note, that is it some error that I am committing, or is it a coincidence that we are getting zeros? Nobody pointed out what exactly was to be done at that point of time to remove or to actually check that coincidence, because I had told you that the positive value of this indicates that as the x would increase, y would increase. For example, you have x and y. If x is increasing and y is increasing, then the covariance is positive. When x is increasing and y is decreasing, or y is, pardon, I would write here x first of all. So x, when it decreases, when x decreases, y increases. In these cases, covariance would be negative, and when x decreases, y also decreases. In these two cases, covariance would be positive. Fine, I had told you this. But interestingly, that day nobody pointed out that despite getting the sum of individuals of these by subtracting the mean, of course, when we calculated those sums, we got 0. And interestingly, everybody said, okay, that might be a coincidence. You've taken the same ratio while changing the value. Exactly. Still, nobody pointed out that we are trying to calculate the cumulative sum of their products. And that's why I deliberately did that I should go ahead and show them the zeros, and then somebody would come up with this. But nobody came up with this. And the next day I went ill and everything was stopped. But from here itself, we'll begin today's discussion. और अभी मैं वो गलती बताऊंगा ना, तो सब बिल्कुल एकदम ऐसे हो जाओगे कि यार शिट, ये तो ध्यान नहीं दिया. Fine. Look. For example, you have x as a number of, I'll take the same example again, number of hours studied. Fine. This is not a straight line. I'm not liking it. Technically, it is a straight line, but it has some angle to it, and I want an absolute line like this. Good. And marks obtained. Fine. These are two variables. We had taken this example. Say somebody studied for 2 hours. He got 30 marks. Somebody studied for 3 hours. He got 40 marks. Somebody studied for 4 hours. He got 50 marks. Somebody studied for 5 hours and he got 60 marks. Fine. This much is clear. Now if I calculate the means, let's go ahead and calculate the mean. So x bar, what does x bar come out to be? 5 plus 4, 9, 9 and 3, 12, 12 plus 2, 14. Rather, I would take some example like this, which gives you a better chance of calculating things. Fine, let's make the calculations easy. I'm not changing the ratios, but okay, fine. Let's go ahead with this data set only. Why to change? So 14 upon 4, this roughly translates to what? 4 3s are 12 and then 3.5. Fine. So that is what you will get, and if I'm correctly calculating it, is it? Yes, it is. Fine. And when I go to y bar, let's calculate what does it give. So 60 plus 50, 110, 150 and 180. So you basically get 180 upon 4. Me being the true blue engineer, I'll go ahead and I'll calculate the same with the help of calculator. 180 divided by 4, and that comes out to be as 45. Fine. So this is 45. Fine. So now you have both means. Now what I'll do is xi minus x bar and yi minus y bar. What will happen? 2 minus 3.5 minus 1.5 minus 0.5, 1.5 and 5 minus, pardon, this would be 0.5. Fine. And 5 minus 3.5 is 1.5. If you carefully see, this was a situation that we had, a similar situation we had where the cumulative sum of all these were 0, isn't it? Last time, didn't we have the same thing? Let's go ahead and do for this as well. 30 minus 45, 15, fine. This would be minus 15. 40 minus 45 minus 5, 50 minus 45, 5, and 60 minus 45 would be 15. Exactly same situation we had. Didn't we have such situation? Yes or no? Didn't we have such situation last time? Sumant, good evening. Sumant, if you correctly remember, last time we had similar situation, isn't it? Tell me yes or no, that we were calculating the sums of it and we were getting zeros, isn't it? Go ahead, tell me that fast. फटाफट बताओ यार. Tell me in the chat section, was the situation similar when we discussed about covariance? Yes or no? Evening, evening. Guys, I'm asking something. Was it yes or no? So if the situation was similar, type out yes. If it was not similar, type out no. Simple. Yes, situation was similar. Interestingly, nobody pointed out that yes, this can be a coincidence that you got the sum of these as 0, but nobody looked at this formula. This formula never said to actually go ahead and sum this out, isn't it? This formula, I deliberately did this so that for the next class I could explain you this. However, in the next class I felt ill, but this formula never said that you individually sum them. It is saying the sum of products of these two terms. Basically, what I'm telling you is, what we were doing was this. Were we supposed to do this? No, we were not supposed to do this. This is wrong. But nobody applied this logic, interestingly. And why I committed this? The reason is, always in statistics, this mistake is the most frequent thing that happens. And I deliberately did that let's see and figure out. I dropped few hints in the class, but unfortunately nobody looked at that. And now nobody would ever forget this mistake. Fine, you would always remember this. So what you have to do is, you have to actually multiply them first. So basically you have to calculate this at the first onset. Fine, minus, let me write what is it doing. Let's do it like this. Yi minus y bar, and fine. Okay, so first you need to do this product, then you had to do the summation, then you had to do the sum. Okay, So let's do it. So it would look like 22.5 if I'm not wrong, but I'll still be a true blue engineer and I'll go ahead and I'll calculate this using a calculator. Yes, I'm correct. This would look like 2.5 if I'm not wrong. This would be negatives. Fine. Let's check. Minus 0.5 into minus 5. Yes, minus 2.5. Then this becomes 2.5 and this becomes 22.5. Okay. Now, when you had to add these, at that point of time you could have said, yes, this is coming out to be 0. Fine. Yes, this can come out to be 0. This can come 0. No issues, no worries in this. Yes, the person who was saying that you had taken the same ratio while changing the values, because here the ratio is 1, here it is 10, so it would not vary much. Yes, at this point you could do the summation and you could calculate 0. Yes, at this point you could say that it is not varying at all. Fine, it is not varying in a very significant manner. At this point you could calculate it. But would you say that zeros happening here affect the covariance? No, not at all, first of all. Secondly, now I will take a slightly different example and you will realize better what I was trying to say. Let's take a similar example, keeping the x same to 3, 4 and 5, and for y I'll change the rate of variability or the rate of change. I'll vary it here. See, we did here, it was 30, so let's go ahead and keep it like this: 30, 35, 40 and 45. Fine. With this, let's change, or rather I would make this 45 as 60. Fine. Let's absolutely differ this out. So in this case, what would happen? Let's calculate the means again. You know x bar is nothing but 3.5, right? You know that. But for y, 30 plus 35 plus 100 simply, so that becomes 165 divided by 4, 41.25. Y bar is 41.25. Now if I calculate x minus x bar, fine, xi minus x bar, I try calculating it, what would it be? So these values would remain same, fine, because nothing has changed there. Minus 1.5, minus 0.5, 0.5, 1.5. Now see, yi minus y bar, it is still submitting to 0. When you sum all these, it will be still 0. However, it would never affect covariance. Now, when I do this with the y, fine. So 30 minus 41.25, this comes out to be minus 11.25, fine. And then I subtract it from this, so minus 6.25, 35 minus 41.25, this becomes 1.25, and what does this become? 60 minus 41.25, so this becomes 18.75. Now in this case, this is actually submitting to 0. If I do the summation of all these, it would become 0. Will this become 0? Will this become 0? See, 11.25 plus 6.25, so this would be 17.5, fine. And this is actually minus 1.25 because I am subtracting it from 40. So 40 minus 41.25, and I add this plus 1.25 to it. So basically, if you summate them, this would also become absolute 0. But when you do the product, does it remain the same? Let's check. Fine. Now let's do the product of them. So what would it become? Minus 11.25 into minus 1.5, fine, 16.875. Here also, if you correctly see, these all values would have been plus. So can it be 0? No, it cannot be 0. Here I committed another error. However, this was not deliberate. Fine, I didn't realize. However, here also, you will not have any negative value. These are positively variating. Now, covariance should be positive here. Now it can be calculated. We'll calculate in both cases. Fine. Here also, if you see 6.25 into 0.5, let's try calculating this into 0.5. So this is 3.125. Here 1.25 into 0.5. This becomes 0.625, but this is in negative, fine, because here only one symbol is negative, and then 18.75 into 1.5, this becomes 28.125. Now if you submit all these, will they be negative? No, they won't be negative. And when I'll subtract them, fine, I'll subtract this particular result from the sum of these three, you will have no changes. Basically I'm saying you add all of them, you will have a result which would be positive, divided by n minus 1. What is n minus 1? 3, because you are having 4 outputs. So 4 minus 1 is 3, you will still have a positive result. Am I clear? Is there any doubt? Because this is at times a confusing topic, but here also if you had seen, there is nothing in which you can say that this particular output would give you a zero covariance. Would it give you a zero covariance? No, it won't. See, 2.5 plus 2.5 is 5, fine. So 5 and 22.5 plus 22.5 becomes 45, fine. So this becomes 50. So if you calculate covariance of x and y, this becomes 50 divided by 3, which roughly translates to what? 3 ones are 3, and then you have 3 6s are 18, and then again 16.66. So somewhere there, this would be your covariance for this. Is it clear? Is the covariance clear now? Yes or no bolo? Fatavat batao. Is the covariance clear to you by far? Tell me this. Fine. And here, if I calculate 16.875 plus 3.125 plus 28.125 minus 0.625. So this becomes 47.5, and this is the summation of all these. And if I calculate covariance of x comma y, then what does it become? 47.5 divided by 3. So this becomes 15.8 roughly. Now if I tell you that this is roughly 15.8 and this is 16.66, which is stronger? None is stronger. You cannot tell which is stronger. So great that you guys are understanding. None is stronger, and that is why we need correlations. The topic for today, which was correlations, that is why it is needed. That is why it is needed. The reason being that here, when we tried checking, first of all, these individually can be 0, see, but their products would have a positive sum if they are positively covariating, fine. If they are positively covariating, their covariance would come out to be a positive number. Is that clear to you people? Now if I come to correlation, and that is why covariance was so important to understand, because covariance ranges from minus infinity to plus infinity. Now in this case, when it is ranging from minus infinity to plus infinity, when it is ranging from these two values, correlations are needed, because here you cannot tell which is stronger and which is not stronger. For example, if you are saying that x and y, you have two variables xy, you have two variables m and n. Covariance of x and y, you say it is 30. You say covariance of m and n is 300. You still can't predict which exactly is strongly correlated together. Fine. You cannot actually predict which value is stronger, which should be given preference out of these two. You cannot say that. But correlations help you there. Correlations actually put a range from 0 to 1 when we talk about Pearson's correlation coefficient. Now what is this correlation? We'll understand, don't worry. Fine. So this Pearson's correlation coefficient says covariance of x and y upon standard deviation of x and standard deviation of y. Fine, product of them. Fine. You basically calculate this and you get your Pearson's correlation coefficient, but this ranges from 0 to 1. Fine. That is generally the 0 to 1 range. Fine. Is that clear? First of all, tell me, is this much clear? Is this much clear? Now this 0 to 1 range that I am talking about is for all the positively correlated. Fine. Positively correlated, and from 0 to -1 is for negatively correlated. Is it clear? First of all, tell me this much. Is covariance absolutely clear to you now? Tell me that much, so that you can understand that why you need this. You need to represent strength, which is better. I'll show you how you can actually go about correlation. But first of all, tell me, is covariance clear to you people? Because we are heading towards the end of descriptive statistics. Great, great, it is clear to you. Great. So from 0 to 1, it ranges for positive correlations. From 0 to -1, it ranges for negative correlations. Is it clear? Now in this case, whenever you have a value more towards positive one, fine. If you have a value 0.625, this is correlation of x and y. Fine. So this correlation is actually represented by, I'll show you the symbol for this as well. It is actually represented by this symbol. Fine. Pearson's correlation coefficient. Fine. So if for x and y, this is 0.625, it is represented by this symbol. Fine. If it is 0.625 for x and y, and for m and n, it is 0.75. Both are positive values. In this case, this is a stronger positive correlation. Fine. This is a stronger positive correlation because you have a range. You have a range from -1 to 1, which is the actual range, where 0 is the midpoint here. Fine. So here it is negative correlation, here it is positive correlation. Is that much clear to you? ये सबको समझ में आ रहा है? Is everybody clear with it? Because this is actually the power of correlation. Why did we need correlation? हमें चाहिए क्यों था? Why on the first place we needed it when we were having covariance? The reason was that for having correlation coefficients, for having these correlations, we needed something that can actually tell us or truly represent what exactly is stronger in terms of correlation. Which two variables can be said that they are strongly variating together? How do you find that? How do you find that which two variables are actually very, very sensitive to each other? Fine. In that case, correlation comes out. Fine. And positive correlation, where if x increases, y increases. If x decreases, y decreases. For that, positive correlation. For negative correlation is x decreases, y increases, y decreases, x increases. Fine, that much. But if I am having Pearson's correlation coefficient value for two different data sets where you have x and y variables and m and n variables, I can definitely say they are strongly correlated. You also have one more technique of correlation, which is Spearman's correlation coefficient. But here today we'll stop at this. Fine. If you have any doubts, you can put in my community. You can join the Telegram community that we have built for this. And I would request support team, please drop the link to my community. That would help you out. Fine, that would help students. Also, you can find these notes in that community. So join that on Telegram. And alongside that, whatever knowledge you're getting it here, keep spreading it as far as possible. Fine, keep spreading it. Keep doing good for others without any expectation. Good will always come back to you. And remember the mistakes that you commit. Whatever mistakes you commit, remember them as it is. That would help you out. Fine. So I hope from today's lecture you would never forget covariance. You would always remember what mistake you can commit in covariance, and that would always help you out. Alongside that, if you have any doubt, shoot that up. Otherwise, I'll wrap this session. Most welcome, most welcome. If you have any doubt, you can put it in the live chat section. Great, great. So everybody is clear with it. And with that, I would wrap this up and would always tell you that go ahead, spread as far as you can. Go ahead, spread this knowledge. And alongside that, एक विमर्श की परंपरा डेवलप करो, ठीक है? Try making a society which is well informed, which can discuss things rather than being at two extremes. Have a wonderful day ahead. Bye bye.